Okay, so today I'm going to talk about two models, the OSI model as well as the TCP slash IP model. The OSI model is a basic, not a basic, but it provides a framework that dictates how network devices send, receive, as well as interpret data. And the TCP slash IP model is a practical framework that was designed around operational protocols that form the core real world of internet working. Okay, so now let's see the comparison between the OSI model and the TCP slash IP model. The OSI model is made up of 7 layers. The seventh layer is called the application layer, which provides a network access for software applications. Basically, it provides a user interaction between the user and the software application itself. That's it. Now, sixth layer is the presentation layer. It translates data from the fifth layer to usable data. So the fifth layer is the session layer. This session layer, it manages sessions. Basically, it establishes, maintains, as well as terminates communication sessions between software applications. So, for example, you log into an account, you begin the session, and then you log off the account, you end the session. That's it. That's all the layer does. The transport layer, it is responsible for end-to-end host communication. So end-to-end host communication, there has to be two participants in that relationship, I think. So I'm the sender and Prof or whoever will watch this video is the receiver. That's end-to-end communication. But within the transport layer, there is something called the transmission control protocol, meaning it is a is a form of communication between devices that guarantees the reliable data transmission as well as data delivery. Transmission and delivery is the same thing. Data delivery via a three-way handshake and acknowledgement, meaning the transmission control protocol, the TCP, is responsible for making sure that data is sent out the same way it was sent, is received the same way it was sent. So basically, when Prof watches this, this is TCP, basically. So the network layer, which is the third layer, it handles logical device addressing using IP addresses, as well as path selection using routing across independent networks. So it will direct data and keep track of the data using IP addressing. That's it. The second layer is the data link layer. So in the data link layer, it will receive the data from the network layer and add the physical MAC address onto the data. But the physical MAC address is not of the data, but it is of the endpoint. In simpler terms, it adds the destination. So the network layer sends the data, it randomly sends. So it randomly sends the data, and when it reaches the second layer, which is the data link, it will then receive a destination. That's it. Now the last layer, which is the first layer, the physical layer, it transmits raw binary bit streams over physical hardware. The physical hardware being copper cables, fiber optic cables, in a way, radio waves, in a very abstract way, radio waves. Now that's the OSI model. The TCP/IP model now has 4 layers. The 4 layers are application transport, internet, and network access. Now, the application layer is made up of 3 layers from the OSI model, which is the application, presentation, and the session. This layer will be in charge of user interaction, interaction, user interaction, and software interaction. It will be in charge of translating the data into usable data, and it will be in charge of managing sessions. Hence, these 3 layers make up this one layer. So the transport layer in the TCP does the same thing as the transport layer in the OSI model. It is responsible for end-to-end host communication. Again, 2 people or 2 devices have to be in that relationship. It takes 2 to tango. So basically, again, there's a sender, prof, or whoever's watching is the receiver. That's end-to-end host communication. That's it. Now the internet layer on the TCP is the network layer, which basically is providing a path for data and keeping track of the data. That's it. That's it. Now the network access layer is made up of the second layer and the first layer of the OSI model, which is the data link and the physical layer. Basically, this layer is in charge of giving the data that comes from the internet layer a destination, and it transmits raw binary bit streams through physical hardware. Basically, it will take the data, give it a destination, and the data will use the fiber optic cables to reach where it must go. If it goes to Natal, it will reach it. Yeah. Now let me go down here. So basically, this is the different layers. You see, application layer, user interface, and software interactions. What did I say? What did I say? Tanko. Presentation layer. It is data encryption, compression, and formatting. That's it. That's a form of translating data into usable data. Which data did it get from the 5th layer? The 5th layer is the session layer. It manages sessions. Wow! What a wow! Then the 4th layer is the transport end-to-end communication. 2 people. It's a relationship basically. Network layer is IP routing and logical addressing. Basically, send out data and keep track of the data. That's it. Data link gives it a destination in a physical transfer or destination, and the physical layer is a binary transmission over physical medium, which is copper wires and fiber optic cables. And then now the TCP is the application layer. The application layer is made up of 5, 6, 7. The transport layer, host to host. The internet layer here's it's interesting but not interesting. So it uses packets and routing. So data can be typically data can be how can I say this? Data can be sent using like Go. Devices can receive Go data. It receives it packet by packet, one tshwara, like byte by byte. Like it's but yeah, byte by byte, one tshwara. Danko. Then yeah, basically that's the end of my presentation. From this comparison, to sum it all up, TCP is how the internet actually works, while OSI model is the universal framework engineers use to explain, diagnose, and troubleshoot how the internet works. That's it.